Just wanted to can we say the configuration, right?
Mm-hmm.
And uh, uh, demand configuration and SNOP
Your voice is
configuration.
your voice is breaking, Deepak.
Okay, now is it good?
Better. Yeah, please tell me.
So when we say configuration, right? Demand
Uh,
configuration.
but Deepak, it's still not audible, Deepak.
Uh, just a minute. Audio options. Okay, is it now?
Yeah, yeah, better. Yeah, please tell me.
So when we say configuration, so maybe configuration for demand and configuration for supply. So is there a major difference between them?
Configuration for demand, configuration for supply. Yes, yes, there would be a lot of difference, right? So, like if because the demand planning would be done at a finished good level, and for maybe customer facing thing, um, we might have to create different key figures for some forecast adjustments, and we have to create some new planning levels because the business might want to do forecast at a brand level, then they want to disaggregate to SKU level, etc., etc. So that involves a separate configuration itself, where we have to come up with different key fixes, etc. Whereas supply is more of a building the entire supply chain, like transportation lanes, bomb structures and resources and stuff. So again, even in that, so there would be some inputs which goes into the supply planning. If you're running an optimizer or a heuristic, there would be some inputs like quotas or some costs or some available capacities and etc. And even after running the supply planning algorithms, like a heuristic or an optimizer or something, so the results would still be taken, and then they would be doing something else. Like in all my implementations, we have also done some cost related. So when I say cost, the supply chain cost. So I incurred $10 to produce a particular product, and I did a production of 50,000 units. So 50,000 into 10 is my production cost on that particular bomb for that product in that particular production location, etc. So there would be other key figures that we have to build on, which uses the supply planning results, and then we have to model something else. So that would require another configuration. And yeah, so basically in the project implementation, there would be two different teams: a demand team and then the supply team. So supply team would be taking all the supply requirements, come up with different key figures, different planning levels, and the different copy operators, snapshot operators, or maybe process chains. So we'll be doing supply planning will be doing their stuff, demand planning will be doing their stuff, and in general on top, if there is a control tower, there would be reporting requirements in general, like all the AOP stuff, annual operating plans, and total overall revenue, and etc., etc. So yeah, so every team has to go through some kind of a configuration, and they have to create these key figures and stuff.
Okay.
Here, the scenario that I think we'll continue. So let me share my screen. I think Amal is not going to join. So the scenario that we went with ahead is the capacity planning. So now this capacity planning, if the supply planning team takes the ownership, then that's fine. But maybe if the capacity planning is a very crucial element in their entire supply planning process, or in general in their planning process, then yes, a dedicated team would be kind of created, and they would be working on all these maintenance related key figures and the master data is required, etc., etc. Okay, so I think these are the key figures that we have created yesterday. So first there is a key field called standard available capacity. So this is at a week, resource, location level, and then there is a final available capacity. So there is some calculation involved. We'll park that aside. Um, and then there is a Amul has arrived finally. Hey Amul,
Hey, Venkat, sorry, I completely forgot
that's
I'm
fine.
on
So
last time.
yeah, we waited for you, and yesterday also you guys didn't turn up, huh?
No, no, I was there.
Anyway,
Venkat, I
mhm.
joined yesterday. No one was there. I mean, no one has started the meeting also.
But no, I was there in the meeting. Like I waited like for like 6, 7 minutes, I think, and then the team also is doing a lot of continuous calls for like 6, 7 minutes, and there are some switched offs, and some people are not picking up the call and etc. Then they gave me a notification that you can drop off. We'll cancel today's call. So anyway, so
So,
if you guys getting late, just drop a message to the meeting coordinator because he's the one kind of a Spock, and he lets me know whether to stay in the bridge or to, you know, come out of the bridge.
okay, yeah,
Okay, so yeah, so we just kind of quickly recapping on what we have configured. So we configured a lot, but from a key figures perspective, standard available capacity, this key figure would say that how much of capacity is there will come as a standard for every resource in every location. There is a maintenance start period. It's a flag, 1 or 0. Then there is if it is 1, that means that maintenance activity is happening. There is a maintenance job duration. So this would be the kind of hours that maintenance activity will go on. This we have configured as an attribute as key figure because this is a static value, and that comes from that would be a part of a master data. And let's say if it is in the real world, if it is coming from S4, so it just says that inside this plant for the robotic assembler for a maintenance job like chemical cleansing, so that takes 25 hours as a standard. So but we want to take that static value 25 and propagate that across the time horizon so that we can do some calculations. So that's why we have made it as attribute as a key figure. And then there is a consumed capacity. This is a calculated again. So uh, so so this goes that if you mark a maintenance job as 1 for any time bucket, system does the calculation that if it is 1, how much capacity it consumes. If you mark 1 for another job 2, how much of job 2 will consume, and it gives a total summation that how much is totally consumed. And finally, the final available capacity is a simple difference between what is my standard available. 168 hours is my standard available capacity, 24 by 7, all 6 days in a week, all 7 days, 7 days in a week, and the 24 by 7. So 168 hours, and then 100 has been consumed, and 68 hours is a final available capacity on this particular plant, which the production can happen. So we did the configuration, we triggered an activation. So now we'll get into the system, and then we'll do some planning on it, and then we'll take it up from here. We'll add more complexity to it, and then so now I'm getting into our planning area called test conf 2. So we are inside the planning area. Oh, it is saying that there are no templates in the test config 2. Okay, I think we just created this planning area and activated it. So, okay, we need a planning template. I mean, I can very well query it on this Excel view itself. So I can go and say without template on current sheet, I can bring that up, but it will not be uh, good. So let's go and bring a template. So like in the real world, the IBP in the unified planning area, you will have a bunch of templates, so you can pick up a template and can start building on it. So but for now on, I'll get into another planning area, so where I have some templates, so I'll just bring that up. So first I established a connection to the planning area that I want. So there is a template called demand planning here. So this is a template. Let me now log out. That means I'm closing the connection. Now I'm again jumping into our planning area, test config 2. So now I'll attach this template with our test config and I load it into the cloud so that this would be available. And before that, let's go and build some master data. I think there are no master data available. So we need locations, some production facilities, and then we need some resources, and we have to create some maintenance jobs. Maintenance activity is a master data, custom master data. We created that. And then there is a location resource master data where we assign a resource to a particular location. You can have 50 assemblers, robotic and manual. You have to extend them to a particular plant, right? So here, what is that? Those location, resource, maintenance. So the compound master data. Now let's go to the location. So I should have done it through. It is saying no data found. There is no data. Of course, we know that. We going to load it now. I'm usually I should run upload a data integration job through a flat file, but yeah, I can also do this thing. So just coming here, saying that in a plant on the word. Um, two plants. Yes, the data has been loaded. Now go to the resource master data. It is saying no data found. Yes, there is no. So now I'm loading the resource IDs. So I'll say robotic assembler 101, 201, 101. Let's just say saving it. Now maintenance activity. I think we have loaded some maintenance activity already. Okay, so three attributes in it: chemical cleansing, dry vacuum services, oil wash. John is a technician responsible for these maintenance activities. Steve is responsible for oil wash. These two are preventive maintenance, whereas oil wash is a shutdown. Okay, now comes to the location resource. So this is where we assign 4 resource IDs to plants. Okay, I think this is wrong. Yes, robotic assembler 101 mapped to plant 101. Robotic assembler 201 is mapped to plant 201. Again, with the case of manual 101, 101, 201, 201. Okay, great. Saving it. And there are some other attributes. If you see here, they all are supply related stuff. Once we go there, we'll talk about it. Like, what is a constraint type? It is a F means a finite. If you leave it blank, that means it's an infinite. So there would be no, capacity restrictions on it. So when you run an optimizer, it will not hold its production based on the available capacity here. So there is one capacity supply, that how much is available capacity. If you want to expand, you can say that I can expand it to maximum, like 168 hours is a standard available 50 is my expansion. That means I can do over shifts, over time, and there are some time indicators, etc. So we'll see that once we get into supply planning. But for now, you know, this is a custom master data again we're building. It is called maintenance job, location, resource, priority of the maintenance upgrade. So now this is where the mapping comes in. So how we map. So all three jobs. So plant 101, robotic assembler undergoes all three jobs. The duration is, I'm just giving some random numbers. Let's just say, let's go with this. Robotic assembler is the most advanced. So I would say just 20 hours, 30 hours, but whereas oil wash, let's say it takes 60 hours, something like that. And then again, the same jobs will be done on the, so this is where, so if you don't want anything, let's say, um, you don't have to do dry vacuum for the manual assemblers. So manual assemblers usually take a lot of time, just saying it. Okay, now the same bunch and to the, so maybe in the real brave world, all these things might come from S4 system. Who knows it? Once we build that integration, so just give 10, 10, 10. So priority of the maintenance job, I'll give oil wash as the highest priority anywhere. But in the manual assembler, everything is high, let's say. So this is for your reporting purposes, your filtration purposes, your, your effective planning purposes, etc. If you have this attribute and if it is holding high, medium, low, maybe you can assign a particular high priority maintenance job to a particular user group, low priority to a particular user group, or etc., etc. So the importance of these characteristics. So what all we can do. So yes, we have built our master data. Okay, so let's come back here. And so what else we have to load from a key figure? But I think only one key figure, that is your standard available capacity. Because this is a standard key figure. This is a standard capacity that you require, and then you have to load it. So, and rest all are calculated ones. So let's say here this is a manually loaded, or maybe it has to come from S4 or something. This is a calculated. I would say backend manual loaded. Maintenance start period, planner has to go and specify that this is a manual entry. And job duration, this is a system, the system calculated. So guys, when you guys go with, as I told that there would be different teams working on in the same IBP implementation. Like, so we'll be coming up with some kind of a template like this as a team. So we'll be going and updating all our configuration in there, especially the key figures and then the planning levels. So, and then we also go with some kind of a naming convention. If it is a demand planning related, we give a name called ZDP, and the technical name, so not in the key figure description, business description, but from a technical perspective as a consultant, so, we're going to take care of the back end. So we'll give something like ZDP. So here, I think I gave a naming convention called M job so that I can uniquely identify all the, okay, is this? Yeah. So these are all the, M job, Z M job, start period, etc. So if it is a demand planning one, you have to create a ZDP. I'm just saying as an indication, as a best practices, so that by saying the key figure technical name itself, you will be understanding that, okay, this is a demand planning team's element. The second thing is that you have to make a tracker like this, and then you have to specify all this stuff, that what is this key figure, what is the purpose of it, and then this, like, the source, how this key figure would be loaded. So it could, some key figures could be manually loaded. So because there are just 5 key figures, now it is making sense. But imagine like some planning areas will be having almost like 1,000 key figures. In my second project, we have almost 1,300 key figures are there, and SAP came into the picture and they said that it's going to hamper your cloud performance because you have taken a very restricted cloud space. So the key figures can shoot up to any level. And if you don't specify the source, then kind of this thing. And if it is a system calculated, you have to create another column and then say that what is the logic, how the calculation will happen. And if it is a manual entry, the planners will be well aware that, okay, this is a manually maintained one, so I have to be very careful about the way I know what all I punch in here. Okay, so now let's load the standard available capacity also here. So let's go here, master data workbook. Again, I can do it through a load file from a data integration job in insert and update mode, if you guys remember, or I can do it from the master data workbook only. So here I'm coming here in this drop down, I'm picking up the planning objects. Now it gives me the planning levels. I need to go to that weak resource location. So I think here we have it lists all the 7 key figures that are there. There are 7 key figures that were configured at this level. So I'll go and pick up the standard available capacity. I'll say this is in edit mode. I'll go to the time. I'll pick up the current time bucket 24, and I'll click on OK. Then system opens up another kind of a CSV file, and it is saying no data found, and obviously there is no data. So now here I need to maintain this. What is a key figure? And obviously the key figure has to match with the this is a key figure, standard available capacity. And this is 168 hours across. I'm saving changes. Can give a comment. Okay, so yeah, we're done with this. Back end manually loaded, we did this. Now let's go back to our planning view. So this is having some crazy statistical blah blah blah. Now let's go and edit this view. So we want the location ID and the resource ID, and then the maintenance job ID, key figures, standard available capacity, and then not job duration. Okay, we'll also pick up the job duration, and then the stocked period, and then the consumed capacity, and then the final available capacity. Okay, clicking on OK. It is saying there is no filter. That's fine. Okay, this is all kind of cluttered. Just please bear with me, guys, here. So yeah, so it's all looking crazy, right? Let's do something here. Let me go to the standard available capacity. I'm going to do some banding here. I'm adding a member, key figure member. Standard available capacity. So this is, come on, this is Calibri. Format cell, border. I'll have a border on top. Okay, we'll come to the label. I also want to have a border on top here. Great. Come back to forecast. To IBP, refresh. Oh, is it too much? Okay. Format. Or maybe this. I think this would do. This is what usually we follow. Some just a dotted border so that it differentiates planning combination to planning combination. Okay, so yeah, this is one set. Plant 101, resource manual assembler. You said only 2 jobs, that's why 2 jobs are coming in. But whereas robotic assembler, 3 jobs are there. First key figure is standard available capacity 168. Final available is also 168. Why? Because there is no maintenance happening. So now let's do some maintenance here. So chemical planning, I'll 25th period, I'll say 1. I want chemical. I want to do chemical. This I also want to do oil wash. Okay, I'll go and save the data. Okay, the final available is -12. Crazy. Let's put an alert on this, maybe when we do the configuration. So but for now on, so you said you're going to do 1 as that means 80 hours it will take. You also said oil wash is 100. So the consumed is 80 here, the consumed is 100 here, so that is 180. Final is coming in -12. So now we'll go step by step, guys. So first we'll explore the attribute as a key figure functionality. If you guys remember, we configured this job duration is a CO2 M job duration. This is an attribute, and then we created this as an attribute as key figure. So that value is being copied across this thing. Okay, so now let's change that and see. So where was that? So this is manual assembler, chemical cleaning. You said 80, right? So now I'll go and change this to 11. I'll save it. Number of records changed 1, number of records changed 1. So everything became 11, 11, 11. So you guys are getting me? The attribute as a key figure. So attribute means it's a static value, just a 1 or like some value, integer value. If you model that as a key figure, then system extends that static value to the as a key figure, and it just copies all the values across the horizon that you specify in the configuration part. So the typical use cases would be the unit prices that we come from S4 that comes from S4 system for materials. Let's say there is a finished good, and then there's a unit price maintained in Mara table or and somewhere in the S4 or ERP system. So and then they bring that value like $5, so that comes and sits in an attribute as a key figure. So now you can take that finished good price and use that in different calculations for revenues and for the cost you incurred, for the profit you make, and etc. etc. So it's all like $5 across the time horizon. So next month, like let's say from this is June month, July, August, it's all $5. And even if you have a value in December 2019, some quantity is there, you multiply it with the unit price, you get the revenue. Fine. Next month they did something in the FICO module. Something just happened, and the price has increased a bit up, so it became $6. So when interface is happening next month, let's say that interface is running every month. Usually it happens also like every day. So let's say the interface ran on next month. So now system updates that 555 to 6, but it will not update the previous value, that is the June month. Why? Because in the configuration you said from period is 0. That means from current period you have to copy the value. So when the interface is running on July, system would update the $6 from July till the horizon that you specified. So the history values would still be there. You guys understood or not?
Yeah, Venkat. So one question. So
Hmm.
is this specific to, I mean, in this example, is it specific to this maintenance ID, resource ID, and location ID, right?
Exactly.
Okay.
Yes. So let me say this is um, mm, this is maintenance plan. Okay. Now let's create a detailed view. So I'm saying clicked on from, copy current sheet. So here I'll say this is overall plan, or maybe final plan. So here maybe, so this is another view created for supply planner where you don't want to know what maintenance activities are happening, blah blah blah. So there is no maintenance in his dimension, so you don't want to know what jobs are running, let's say. So he just wants to know what is my available, what is the consumed, and what is the final available. So now system does the aggregation. So system shows this up. So he says that in my plant 101 for manual assembler, 168 is my standard. The maintenance activity is consuming 111, and I am left with only 57. So I have to do my production with only 57 units of available capacity. Okay, so like two views. So in the same view, so this is a detailed view where planner can go and punch us in, and he sees the duration that it is taking. So if it is cluttering, if it is cluttering, so if the planner knows, if the maintenance planner knows that how much of the duration that every maintenance activity takes, then there is no point of listing the job duration also. Just hide this up, because we have to make our planning views as cleaner as possible, put very less data, and then you also need the consumed capacity also, also take this off, how much is consumed. It's a kind of a basic math, and they don't want to. I'm just saying that the kind of different ways of creating this template. So all you have to do is punch in ones and zeros, ones and zeros, ones and zeros. So keep one here, and then keep one here, save the data. Okay, so I think chemical cleaning only taking 10 units of the capacity. That's why it is 157. Here also 157. This is it. Okay, now let me save this template. We need at least one template in this planning area. It's called maintenance planning. Okay. So let's do give. Just want to show you something, guys. The heat maps. just just giving that some. Saving it. So just want to show you the heat maps, how they'll come in handy. So you guys are understanding, right? I mean, you guys are following it up, right?
Uh, yeah, with some challenges actually.
Oh yeah, please go on, please shoot. So
So we did at attribute level, so that I didn't understood.
what is that? Or maybe I'll say one thing. Once this is done, once or this session is done, maybe during the course of the day, maybe revisit this video, or think about it for some time, try to digest it. Because this entire thing is happening as per the planning level. What is planning level? Planning level is nothing but the it's a combination of all master data attributes, right? So digest it, and if you still have questions, tomorrow please shoot it up step by step, question by question. We can handle it. So I'm just creating a view, the views that would come in handy, because as a consultants we have to suggest our things to the business, because what's the best way to report or plan, or the ways to analyze it. Okay, so now I'm plotting a key figure for job duration. Sure, that will work to revisit the videos and then shoot question. Great. Job duration. No, not job duration. Yeah, not this. I'll say start period. That means when when a maintenance job has to happen. Okay, system said 26. That means 26 jobs are happening, because start period is 1 or 0. Now I'm grouping by week. Okay, and then by the location, and by the resource. Okay, so now I'll change the view to a heat map. It just got stuck. Saying doesn't have a filter, that's why it is. That's fine. And this is going to 2020 also, not required. Yeah, this is getting, I don't know. I don't know, when the session happens, this gets crazy. Let me just go and put some filter. I will say from current period to, yeah, I think this is fine. Some periods are there. Okay, so you can see this. So you can see ones and zeros. So one means that there is a maintenance activity happening. Two means there are two maintenance activities are happening. So inside the manual assembler. So this is one nice way on, you can just further beautify it. Let me just arrange the week should go to the top. Hmm. These are the weeks, and this is the plant 101, plant 102, and it is showing no value. So I think I have something called suppress the nulls. Think it will just take off those values. Take off those cells. I think. Okay, it is still showing nulls. Hmm. This one. Okay, I'll off this thing. Now it is showing the darker and the light blue. Darker means two maintenance activities are happening. So let's say we want to have the visibility of the maintenance job also. So let me bring up that dimension also, maintenance job ID. So yeah, again, let me focus on the grouping by the sequence of it. Let's say week should go on to the top. No, I think, yeah, 1 second now. Yeah, you guys have to, come up something like this, and then present it to the business. If they like it, they'll take this chart as it is, or they can do some tweaking on top. So yeah, so the kind of, this is how you can create something like this, for a particular region. If there are, some plants and etc. So they just see this heat map and they'll know that there is activity happening. So with this, we'll know that too much of activities are happening in this time frame. Why the oil wash and chemical cleansing are happening side by side on one single resource in one single plant. Not supposed to do that, right? So I mean, the maintenance activity, if you have done it once, you shouldn't happen it like, every now and then, right? You're getting it, right? So how to use the analytics also in here. Now let's come back to the view. I know this might go over the top because we got some break. This might all. So what we're doing today, so what we did is, yeah, first we verified the configuration, all the key figures and everything, and then we loaded the master data. We loaded the locations, we loaded the type of resources are there, and then maintenance jobs are anyway there. So maintenance jobs, and then these are all simple master data. Then we did the compound master data, then we did location resource, and then we did location resource, and then maintenance job. So we did all this, and in the maintenance job we also gave job duration, that is attribute as a key figure. Then we loaded the standard capacity, 1 CST hours. Then what we did, then we went with the planning. So we gave specified when maintenance activity has to be triggered. So we used something called job duration. No, start period. Start period as 1 means that the maintenance activity will happen on that particular combination, like that particular time period, week, and on that plant, on that resource, this particular maintenance activity will happen. So after that we have verified the capacity consumed. So this is automatic calculation based on the flag, that is job period, and with the job duration. This is an attribute as a key figure. And then we verified the final available capacity. Right, this is summation of total I mean standard with the capacity that is consumed. What else we did? So we have seen the attribute as key figure, how it functions. Right, I gave a static value, it just populated it across. Okay, and then we did some analytics, that is fine, so some heat map. So now I'll show you the EPM formatting. As let's say the requirement is that the planner has either to enter a 1 or a 0. 1 means it has to start. 0 or null means nothing. That's it. Okay. So how to restrict that? Restricting the user entry. Obviously, I can't make it as a non-editable. It has to be an editable key figure, because then only the planner can go and give one and then save it. It has to be editable, but the entry has to be restricted. So from a configuration perspective, there is nothing straightforward. We cannot do anything. There is another thing that I think this is too early to talk about it, but yeah, anyway, I'll tell it to you. So let's say there is something called as a frozen horizon. Frozen horizon for maintenance activity, that you say that for plant 101, don't give any new plan for next 1 month, because plant 101 cannot take anything in the plant for the current month. So now we are in June, July, August. So this is a requirement, guys. I'm talking from a requirement perspective, and then I did the reverse engineering to the configure. So let's say we're in the June month and we did some planning activity, and then we did the calculation, and then this is available capacities that happened because of the maintenance team, whatever inputs they gave. June is there. Once we move on to the next month, July month, the requirement is that in July month, planner shouldn't change anything. Whatever has been previously planned, system has to take that up. No new changes. That means that in the first 4 buckets, or like whatever it is, so the planner shouldn't enter 1 or a 0. I mean, they shouldn't able to change the values, but they can very well change the values in the August. So they can go and change it. Okay, in August, shutdown maintenance has to be done, we forgot it, there's a leak in the plant, high priority, please do some oil wash in August. You can do that, but for current period, you're not supposed to do that. I hope you guys understood the requirement, but just please keep that in mind. We'll do it later on as a time, as I said, that we'll take this requirement and then we'll make it complex, and then we'll keep on building it. But for now, the requirement is that user shouldn't enter either a 1, he should enter only 1, or just leave it as it is, but nothing else. No 0.5, no 2, no this and that. Okay, how to do that? That can be done through EPM formatting sheet. Let's go in there. And I'm using that traditional classic Excel functionality called data validation. Okay, but combining it with EPM. As usual, I have to add a member. I'm adding the member called job start period. It lists all the key figures. I'll go to the ID view so that they'll get sorted. I'll scroll down to Z key figures. Job start period is there here. So here I'll click, oh, come on. So here, right click. So usually what you used to do here, so this column F, which is having a header name called data, that means how the data has to appear in the planning views. So now if I go and change this to, so we talked about it, right? So if I change this to Abadi, and then if I change, give this a high, this crazy thing, if I come here and if I do a refresh, so whatever you have applied on that particular cell would come like this. Crazy, right? So this is what happens. This we have seen. We keep on working on it, right? In the EPM, we're opening and then doing it. So, but that is not how what I'm going to do now. So again, going, picking up that key figure. I just remove that entry, click on that remove. That particular member would be gone out. So you bring the members, you specify the formatting that you want on that number, you save it, and then you save it. Now I'll come here, right click under. So the moment you click on right click, EPM comes in, and under that EPM there is something called data validation. Just followed it, right click, EPM, data validation. So now here you're saying that decimal not equal to value of 1. The input message you have to say is data input guideline, something like that. The message is please maintain only 1 or null. I think this is good enough for invalid entry, either a 1 or null. Okay, done. This is how it comes, and then here the column H is saying that how you want to use it. So whatever formatting that you gave on that particular cell, so what all you want to do it. So I just want to use the only the data validation in the number format, and then this is the label. uh, cool with the label, I mean no changes, so just say none. See here, I'm clicking on anything, it is showing this thing. So planner sees it. Let's say the planner wants to maintain something here, so he says that there's 2. What? This is not working, I think. It's not supposed to take 2. This is wrong. Okay, 1 second. Let me go here. What just happened? Okay. Mm, no, no, no. What should I enter? This is 1. More. Okay, yeah, so this is it, I think. Please either maintain a 1 or a null. Retry. I'll maintain 1. Yeah, now it is taking. So you guys are getting it? Yeah, cool. Thanks. So yeah, so this is one way, but this is not as per configuration, because we haven't done anything from a configuration perspective. We are not restricting the key field called start period, and nothing we have done from a configuration perspective, but this is from an EPM. And if the planner has to maintain any data, change the data, so he has to come to the Excel planning view, and then he has to, with this thing we can say this is one, say that please maintain either 1 or a null, like that. Okay, cool. Just closing this off. Restricting the user entry. So what we have to do in here, in the APM formatting sheet, and then under the data, um, choose EPM, data validation, and then the rules for validation. And then navigate to the planning view, refresh, and verify the data validation rules. Okay, so this is one, and let's go. So today I'll also talk about the planning notes, another kind of a great future which will make the business planners happy. So wherever there is transparency, they like it. Okay, what is a planning note? Planning note is a note that a planner can leave upon a textual a note, so that the note will be saved onto the cloud system, so that other planners can also see the note that he has left. Okay, so if I go to the so for that you have to make the system. So there is this M job start period. I said that enable planning notes is tick marked. That means it will have the planning notes. So now the data validation is gone because I removed that member property. Now it's all ones or zeros. So now to get the planning notes activated, you need to go to the edit view under the key figures tab. These are all the available key figures. These are the selected ones. You selected 3 and their sequence, and then below that there is something called display planning notes. Here you're saying show from this planning level only. Okay, now what does this mean? So now I give a note here. See, right click, add planning note. I'm creating a planning note. Just leaving a note here. So now a note is been saved. There is this icon comes in, so you click on it, it would show. So if you want to see more details about this note, same, click on right click, show planning notes. Now we'll display the entire planning note. Let's go cell by cell. So this is the first cell. So here it is saying that this is a draft. That means the note is just been drafted. It is not saved into the HANA cloud. What is a note? This is a note that scheduling chemical cleaning activity as per the plant manager inputs. The value is 1. So what value I maintain? I maintain 1. So that value comes in here. The timestamp when it is being changed by. You can edit this. You can delete this. This time period, 25th time period, you gave it, and location you said plant 101, and this is manual assembler. Then this is a maintenance job. You click on OK. Then when you save it, so you see planning view details, cells changed as 0, but whereas planning notes changed are 1. That means one note has been saved. Okay, this has been saved now. So right, if you go and do show planning notes, you will see that there is this save icon coming in. That is, this means it's stored. Now this note is available across. Now I'll say this is 0. Adding another note. Change in plan, postponing chemical cleaning activity to next month in order to meet the production targets, something like that. I can save it. Like it will keep on having notes. So now I do a right click, show planning notes. It would show me all the notes. So first note is this, on this timestamp he made this note, and after that he changed it, and you can also see how the value is changing. So initially there was 1, and after that it has been changed 0 with this note. You guys are getting it? So to have this from a planning view perspective, you have to go to edit view, key figures. If you say don't show, then planning notes will not be showed. So see, right click, there's nothing. And also you cannot even add a note here. So two things. First thing is you have to specify that that first of all a key figure has to be enabled for planning notes. So you go to the key figure and you say this is enable planning notes, and usually we give it for the key figures where there is some user entry, right? And when the user is changing it, and if we have the planning discipline, we'll also let the planner to give some comment, a textual comment, so that others will also know. So like what are we achieving here? So we are achieving the same thing, that is a transparency and collaboration. So like we're also recording the decision. So whatever decision that he has taken, he's saying that he wants to schedule a maintenance activity. He has left a comment on why he wants to have the a maintenance activity there. So that's one from a configuration perspective. Second thing is, if the planning view has to display it, you have to in the edit view, and then so here in the key figures there are 3 options here. First is don't show. That means it will not show any planning notes. Either a planner can enter a planning note. The second thing is show from this planning level only. So what does it mean? So this means that whatever the planning level that you have selected here, so what level you have selected, there are 3 things here. That is location ID, resource ID, and maintenance job ID. So at this level, if there is any key figure which is having enable planning note, only that would be displayed. Okay, let's say there is another key figure called as a production plan, adjusted production plan, where a planner can go and say that how much of production has to happen. So that production plan would be at a different level. Like what is a source ID, we call it an IBP. It's a kind of equivalent to PPM. Not exactly PPM, it's kind of a bomb structure. So the production is at that source ID level. So location, product, source ID level. That means one single product inside a location can have multiple bombs, so multiple source IDs. So that production plan was at source ID level. Even that key figure can take a note, and that you can bring it up here. So you say that adjusted production. So there is this key figure production. So this is an adjusted value, a user entry. But if you select only this from this planning level only, system will not show any note for this. System would show note only for this start period. Why? Because in this view, this sheet has a planning level of location, resource, maintenance job. And that planning level is valid only for this. Okay. If you say show from all levels, that means every key figure would be listed with the planning note. So you guys are getting me? And usually, like, majority of the cases when we make a worksheet inside a template, we usually bind all the related key figures, and obviously we'll not bring production receipts into this sheet. Why will we bring a production receipts until and unless this is some kind of a crossover? So if it is some executive level planning view, then yes, he wants to see multiple touch points. Then he might want to see the maintenance activity and then also production plan and then also the demand, etc., etc. But yeah, usually we'll bundle all the related key figures onto single view. Okay, so coming to so that's about the planning notes, guys. So okay, so here I can also do some reporting at just the, let's say, so we have created something, right? Let's say technician name. What is it? Technician name? Maintenance job technician. I'll say start period. So I'm just giving you guys that kind of reporting that we can do from the config that we have just done. So say that don't show. Okay, say this. So okay, so this John, maintenance job technician, is doing 3 jobs in the week 24. So yeah, maybe we need a planning note and we just save it and say that John is so busy on week 24. He's not a he-man. He cannot do all jobs on one single week. So something like that, Steve, some of you like this. And like, see, I mean, why I have included those attributes. I'm just showing you here now so that you can do some reportings. If there is a requirement to do specific requirements, then yes, you have to uh, pay priority of maintenance job. So let's do this. Now I'm viewing my maintenance plan as per the for the priority, that high priority, the 3 jobs are happening. And then if you want to also have add an attribute after maintenance job ID. So high priority chemical cleaning, that maintenance activity is happening 2 times across your plants. Oil wash is happening 1 time across your plants. And then so this is how you can, for multiple planners, you can create multiple views. And obviously depends upon the requirement. Like, let's say if the requirement is that there is a maintenance planner, he wants to see as per the priority of the maintenance job, and he just wants to have a count that how many in a particular time bucket, how many of these maintenance activities will happen across my supply chain network. I can have 20 plants and I can have 20 resources. That means 20 into 20. Now, let's just say that there are these many places that I can do some maintenance activities. And yeah, so this is it. Okay, I think this has gone too much for today. So yeah, we'll any doubts till now, guys? So tomorrow we'll come up with a fresh requirement and then we'll start this thing. So what I'll do is tomorrow we'll create an alert key figure. So some kind of alerts that if my final available is less than the minimum threshold that I want to maintain, that like this plant 101 for the next quarter, I want to have a minimum of 150 to be available so that I can make my, like whatever. So if I maintain some thresholds, if my final available is less than that, I want to have an alert. And now this is a alert key figure. That means a configuration has to be done, not like a custom alert where we do it in the front end interface. So and so alert key figure, and then we'll take some snapshots. The snapshot, right? So now you take a snapshot of one plan, and then like let's say it's like this is a plan, and then you take a snapshot. And then like after this after the entire maintenance activity is done, means like the maintenance plan is done. Once the maintenance planner said that okay, this is a plan, we'll go with it, you take a snapshot. And then in July month you do some changes. This has become 150, this becomes 140, this becomes 120. So now you can see the comparison that how the plan is evolving, how his plan is changing. So last month you said you're going to do 140, I took a snapshot of it. Now you're saying this plan is going to 150. Why there is a variance? If the variance is like, if you want to have another key figure, let's say there is some kind of a variance. So the variance is, I'm not getting the formula. I think this should do. Or is it? No, I think this is wrong. This is divided by 150. And this is in percentages. Okay. So this is 200. And this is 20. Okay. So let's just say there is this is a plan. You took a snapshot, you're preserving the plan so that you want to compare it with the future. Like that is what we do, right? So what is a plan? Plan is a stick to control your activities or something. So yeah, so this is your snapshot you took. This is a plan, but the plan got changed in July and August. You take the variance that there's a huge variance on August, and if the variance is greater than this much, again I want to have an alert. So or do something with it, or if this is kind of requirements that we have, and we have to do come up with the key figures and write some calculations, and then put something. So tomorrow we'll create the alert key figures and snapshot key figures, and also we'll introduce more this thing into this maintenance activity, and then we'll continue. Any doubts, guys, today?
No, Venkat, I'm good.
Good, thanks. Yeah, so this might and just one small thing, guys. I mean, if you try to map everything with the APO, then this might be kind of this thing, but I would suggest that at least just try to have some kind of fresh perspective. Then this will make more sense, especially the planning levels and etc, attributors, key figures, and this compound master data and stuff. So yeah, yes, Deepak, you have a doubt?
So this maintenance planning, just related to my first question. So maintenance planning, we seeing this. So this is same like we're also doing demand as well as supply in this.
Yes, exactly. So, but like for demand, so demand is a different thing. So demand, even though we need key figures, even though we need planning levels, at what level you want to do planning, you want to do it at product family level, disaggregate to SKU level. So those all mathematical things are there. But in usually in demand planning, there are some stuff like statistical forecasting is there. So you will have a linear regression, blah blah blah, simple moving arrays, something you get it. And then there is a new product introduction. So there is another feature called you are introducing a new product, then you don't have a history for that new product, you want to feed on to another existing product, so that the existing, like iPhone 10 is there, iPhone 11 is coming in, so iPhone 11 doesn't have any sales history, so that they can do some forecast for iPhone 11. So how they can do some forecast for it, so that they can do some production, they can do some transportation, they can make the stock available. So but how I can do the forecasting is the first step. So first you need to know how much I'm going to sell iPhone 11 in July, August, September. There is no history. So what you can do is you can map that to the existing product, iPhone X, and take the sales history of iPhone X and use some forecasting algorithm, like linear regression or ARIMA or something, maintain alpha, beta, gamma, etc., get the forecast. That's one thing in the demand planning. There's also something called as a data realignment. So realignment always happens, right? Like say the product family is shifting from, like now iPhone X becomes a part of maybe their Mac division, let's just say, or maybe you are having 3 DCs, you are closing down all 3 DCs, and you're coming up with something called as a regional DC. So now whatever data is there for DC1, DC2, DC3 has to be realigned to RDC, and then you have some forecast measures, and like you like what is your you said in the August or in the January 2019, you said this is my forecast 100, but the actual is 120, and then calculate all that mean, absolute error, blah blah blah. So these are all the functions are available for the demand planning act, this thing. And then there's always this configuration piece is always there. So you have to create all key figures to support all these three, right? Again, for supply planning, a different story. Supply planning is where you maintain some so here not much dependent on the master data here, but whereas with the supply plannings you have to create whole set of master data, transportation lanes, bomb structures, quotas, and this and that, etc. So you have to touch base on the master data, and then you have the heuristic algorithm, and then you have the optimizer algorithm, and etc, etc. Again, as I said, once you got the optimizer results, you want to do something with those results. Yeah, some results you'll interface it with S4. Whatever production plan you have, you send it to S4 to PP module or maybe PPDS module for more detailed scheduling, or maybe to create that as a production order and do the production, or maybe some results maybe take some safety stock outputs that optimizer is giving in, and then do some tweaks on it, and then do some calculations on top of it, and then come up with some other plan which you will do use it for XYZ purpose. Again, there is a configuration that is coming in. You have to create new key figures, new planning levels, come up with the key figure calculation logics, maybe do some copy operators, this and that. So yeah, so all are like different things. And maintenance planning, as I'm saying, this is a custom thing, so there is no such thing as a maintenance activity in IBP. I'm just taking this as a directional thing and showing it to you that what all can be with the IBP structure, with the configuration structure that IBP gave, with this key figures, planning levels, and this attribute as key figures, and the alerts, and this and that. So what all you can plan. So you can very well take this maintenance job and create something else, master data, like HR master data. You can do some HR planning with it. It might not be robust enough, but you can very well play with HR numbers. In one of the other projects I was talking, we did something called container planning. So container planning means if there is a transportation lane from plant to DC, there are 5 products you are shipping in, then you are shipping 10,000 units. Like every week you have 3 different containers: heavy container, large container, small container. Every container will have a different capacity to it. Product 1, it can hold 10,000 units. Product 2, it can only do 5,000 units, etc. So with that data that you have, and with this plan of ship 10,000 units, and I have these containers with me, so how many containers I'll incur to meet that 10,000 shipment. Will I be ending up using 3 of my big containers or 2 of my small containers, etc, etc. So this is kind of a sub planning that you do, and it requires creating some custom master data called container master data. Give a container ID, give a container capacity, and etc, etc. So yeah, so you have to take this thing and then try to connect the dots, etc. Like for example, I'm saying this container is a master data, and then this will have a container ID, and then a container brand, let's just say Merck, or logistics, Indian logistics, TVS logistics, whatever. So now there's something called a container capacity. So can I make the container capacity as a part of uh, container master data? I would say no. Why? Because the container capacity will be changing based on the product you keep. So that's why I have to create, there will be a master data called product master data already available. So now you have to create a compound master data. It's called container product. So in this container product, what you will do is here you will, sorry?
Yeah, and I got your point, like on the compound thing. Yeah.
Yeah, exactly. Container product. And then here you will say that container capacity. So you say container C101 is my Merck container, big one. So it's Q1, it can hold, if let's say this is like laptops. So this can hold 1,000. But if it is a C1 same container, if you're sending smartphones, I can actually do 2,000. And then use this attribute container capacity, use it for in different calculations, and then come up with some final figures like how many containers I'll incur, I have to use to do the shipment that my supply planning team has given. So yeah, so this is all directional thing. So
Venkat,
once you this,
A quick
Yes,
question.
Abhinav.
So
Hmm.
the container capacity, the example that you are giving, so when the compound key figure that will be creating, or the compound master data, sorry, that will be creating, is it container product or is it container product resource? Because capacity is a resource attribute, correct?
Yes, agree. So, I mean, yeah, it's about the way you interpret it. If you interpret the container itself as a resource, then
Okay,
fine. Or
okay,
otherwise, you can create something like, transportation resource,
got it.
something like
Okay,
that.
got it. Thanks.
Because usually when we're saying resource here, we assuming that these are production resources, like all these manufacturing assembly, manual assembly, robotic assembly. So, yeah,
Got
it's
it.
it's the way that we model everything.
Okay, thank you.
Yeah, so we're not stopping here, guys. We'll spend another, minimum a couple of more days just on the configuration part, and then we'll get into the modules, demand planning, supply planning, etc. And we'll cover up all the futures that are there in the configuration. So with that, I think majority of the requirements can be met. So yeah, with a lot of
Okay.
Z tables and stuff. Okay, we'll touch base tomorrow, guys. Please absorb this, and then tomorrow, guys can shoot up more questions.
So, Venkat, please request these backend people to load this video as soon as possible so that we'll get a chance to.
Oh yeah, sure, Deepak. Yeah.
Thank you.
Okay. Yeah. Thanks, guys. Thanks for joining. Bye.
Thank you. Thank you, Venkat.
Thank you.
This conference will now be recorded.
Okay, so yesterday we have completed the the basic capacity planning. Um, so like there is a standard available capacity, and then there is a job start period key figure. It's a flag one, or nothing. One means that that maintenance activity will happen inside that facility, and then based on the duration that that maintenance activity happens on that particular resource and location, system has to do a calculation in the backend. So at the end of the transaction, once the planner is done with flagging in the maintenance jobs, so he'll be seeing this final output at a location and resource level. So this box is saying that the standard capacity is 168 hours, 168 hours, 168 hours. But because of the maintenance activities that were been scheduled, the planned capacity consumption is 50 and 118 and 0. So this is at the detail level. This is at the as we have seen yesterday. So this is actually at the location, resource, and maintenance job level. So we're going to aggregate that, and then we'll bring that up to location and resource, so that we can subtract this planned consumption with the standard to come up with the final available. For example, on week 2 here on robotic assembler, chemical cleaning is happening, which is consuming 68 hours. Oiling is happening, which is consuming 50 hours. So if I verify, if I view the same key figure at location and resource level, system aggregates both the chemical cleaning and oil cleaning. 68 plus 50 becomes 118. So 118 comes in here. So the standard subtraction between standard and capacity consumed, 50 hours, comes in here. Okay, so today we're going to touch on 3 topics. So the first topic is it's key figures only. First we talk about um, a helper key figure, and then we also talk about an alert key figure, and then we also talk about a snapshot key figure. 3 different key figures today. So when do we when we require these 3 key figures: helper, alert, snapshot? So depending upon the business requirement, and we can use this, and they come in handy. So first I'll tell a business scenario, and then we can see how these things come in handy. So let's just now play at location and resource level. Let's not get into the maintenance job level. So there is a plant, one location. There is a resource called robotic assembler. The standard capacity is 168, 168, 168. The planned capacity consumption is 58, 118, and 0. The final available is 118, 50, 168. So now I'll maintain something called the minimum capacity. So I'll maintain something called the minimum capacity required. So this is another key figure. This key figure holds an input from the planners, that how much of the capacity that they require in minimum for any time bucket on that resource in that location. Okay, so if they say that they want a minimum of 120 hours, why they want minimum of 120 hours? It could be like any reason, like maybe in those periods they have to meet their production targets, and or maybe plant work is one is the most optimal plant. Maybe the robotic assembler is there only in the plant one, so that's why they want to do maximum stuff on the robotic assembler, so that they can get it, they can produce it with a cheap cost, etc., etc. It could be any reason. So they'll just maintain that how much of the capacity they require in minimum. So now the requirement is that, mm, so if the final available capacity is less than minimum capacity required, I want an alert. Okay, and the alert is like this. So the alert should highlight the final available capacity, and then so that the planner will know that something is wrong with the cell, and he can go and take a call on this. Okay, that's the first requirement. The second requirement, so we have specified, okay, there is a, the final available is less than the threshold, but we have uh, in order to do any action, because let's say the maintenance jobs are mandatory ones, and we have been skipping it for quite some time, and we cannot skip in this week 1 and week 2. The planner is, so now let's say if that is a case, we'll give an option to the planners that they can do some overtime. That is a solution, right? So maybe come up with an extra shift, and make another set of workers come in and do overtime, and ultimately do overproduction kind of a thing. So we want the planners to hold that, to maintain that overtime value. So creating another key figure, it's called overtime. Okay, I'm giving the name called overtime required. So now here the planner will go and say that, okay, this is 118 is fine, but this 50 is way low, so I'll do overtime of 50. Okay, so if this is a case, and we need another key figure, which is like, the freezed, something like capacity freeze plan. So now this is equal to, you know um, final available plus overtime. So this is 118 plus 0. So this is 50 plus 50. This is 168. Okay, so this is what, this is a requirement, and so we'll create these extra key figures, and we'll see how to create an alert key figure, so that we can alert on, we can alert this final available capacity, number one. Number two, to come up with these calculations, how a helper key figure will come in handy. Okay, and then the final thing is, so uh, the capacity freeze plan, like mm, once the plan got freezed, we want to take a snapshot of it, so that we want to, like yesterday we have seen, right? So we'll see how the plan will be evolving. So I take backup, not, of that capacity freeze plan, so that it would be stored in a separate key figure, and then I can see how it is evolving, and etc., etc. So snapshot of capacity freeze plan is just taking a snapshot of capacity freeze plan. Okay, so you with me, Deepak, till now?
Yes, Venkat.
Great. So like what key figures we're going to need now?
So now we are going to for minimum capacity, overtime,
Exactly.
capacity free, and snapshot. Right.
Perfect. Source. So minimum capacity source is it's a manual entry, or maybe it is coming from a flat file. Uh, if the planners are well aware of it, maybe they can store it for like entire horizon, that they know that this plan has to do minimum of this, like, or they can come and just edit and save the value. Overtime required is also a manual entry. Capacity freeze plan is a system calculation. Snapshot is also system calculation. No, I'll say this is output of snapshot operator. So we have to run an operator to take the snapshots. Okay, and then there is also an alert here, alert key figure to highlight the final available capacity. So let me go here. So now I'm inside the test config planning area. So first I'm creating this, and these all are at weak resource location. So now there is no maintenance job. We don't need the visibility on maintenance job activity, because we are now doing at an aggregated level. Okay, so now I'm creating a new key figure. I'm inside this key figure app, this thing, and click on start. This is create new. So it is asking for key figure or add helper or an attribute transformation. So for now, I'm creating a helper key figure to store the minimum capacity required. So I maintain the same naming convention, ZM job, min capacity required. It asks for what is a planning level. I'll say the planning level is week resource location. For every week on every resource under every location. Click on OK. Minimum capacity required. Give the name and the description. I am saying that this is a stored key figure, not a snapshot, not an alert. Edit allowed. Yes, it is has to be all editable, let's say. So what are the different options here? First is not editable. That means we cannot edit it. No one can edit it. Next is system editable. That means only system can edit it. How system will edit it? When there is a calculation beneath, so system will, if you write minimum capacity required is equal to a plus b, then only as per the a plus b, system edits the values of minimum capacity required. Or maybe you're running an operator, the operator is resulting the values, the system is editing the values. That means it is system editable. Next is editable in the current or future. So only in the current bucket and future bucket you can edit it, but not in the past bucket. There's a key figure for editable in the past. That means it is editable only in the past, like you're adjusting your actuals, like for example actuals quantity or actual stock transfer or actuals production. So whatever is already been done, it comes into IBP through interface. So if you want to adjust it, then yes, you can say that it is editable in the past. For example, you're running a forecasting algorithm, it requires a sales history. So it takes that sales history and gives the forecast. So while it is taking sales history, you can make that key figure as editable in the past, so that you can go and edit it. It depends upon the business requirement. We have to pick
But
up an option here.
so if we choose the option editable in the past, and if we execute the planning, right? So that will just edit the past, and the current and the future will be same.
No. Here, if editable in the past means the planner can go and edit it.
Okay, okay, okay.
Okay. Oh yeah, we'll just test that out. So I'm saying editable in the past, and then all editable is like across the horizon you can go and edit it. The planner can go and edit it. Okay. So calculated, it's not a calculated. This is coming in. So we have seen enable fixing is not there. We have seen enable planning notes yesterday in planning level for planning notes. We have seen it. Others will see it. So now I'm clicking on input key figures. So M job minimum capacity required is a key figure that is going as an input here. I'm clicking on stored value. Okay, saving it. Okay, so minimum is done. Next is overtime. Let me also create a key figure for overtime. Same M job overtime required. The base planning level is weak resource location. Same, it's a stored. It's editable in the current and future. Input key figures. It is a stored value. This is done. Now we have to write the capacity freeze plan. M job capacity freeze. Now this will have that the complex calculation. Let's write that out. Okay, and it is not a stored, it's a calculated because the values will come to this key figure based on a calculation. So at the request level it is always a sum, the aggregation will be of the sum mode. Now I'll click on this plus add calculation. Now I am writing the calculation. So what is our calculation? So the calculation is that if I go back here, the calculation is if my final availability is greater than minimum, then take the overtime required and then sum it up with the final available only. If clause, if my final available capacity is greater than if it is greater than this, I'll say overtime plus so if it is more than the threshold, then I have to utilize my overtime. If it is not more than the threshold, then that means fine, we are within the limit, so the maintenance activities are fine, so we can continue with the the entire maintenance capacity plan. So if it is not greater, then I'll just take, so if it is not great, if it is not greater than the threshold, then fine, I'll just take the available. So now it is saying that you are selecting the final available and then the overtime. Then where is that threshold? the final available is greater than overtime required. No, it is not overtime required. I'm sorry. I wrote it wrong. If it is greater than the threshold, job minimum capacity required and job minimum capacity overtime required and final available capacity. Click on OK. On plus. So you're with me, Deepak, till now?
Yes, Venkat.
Yeah. So so here, how many key figures we have used? So we have used three key figures. So one is the minimum capacity required, which is a stored key figure, overtime required, again stored key figure, final available, there is a calculation written, that's why it is not stored. Final available is the standard minus standard minus the capacity that is consumed by maintenance activity. Okay, so now let's say, hello.
Yeah, Venkat.
Yeah, you're there. Cool. Yeah, cool. So now let's say that if in any of the key figure calculation, if it can only take three key figures, the moment you bring up on a fourth key figure, system will throw you an error message. Okay, because it cannot hold more than three key figures.
That is the
Just
rule,
for
or
yes, that is a rule. So like let's say how to make this make it okay, let's say let me do one thing. This is overtime required, and let's say there is also another key figure. It's called just to see that error message. I'm just saying this scenario might not even occur in real world. So I'm saying there is something called S4 overtime. Okay, that means in the S4 system, there is overtime that can be done. It says that you can do overtime of 50 and 50 and 50. So this is what you can do maximum. So and below that you'll do some adjustments on the overtime. Okay, so let's just say overtime adjustments. So now here you'll say that okay, I'll do minus 50, and here I'll do fine 0, and here I'll do minus 50. So system takes that S4 is saying that you do a overtime of minus 50, and then you do minus 50 here. 50 minus 50 it becomes 0. Then no overtime has been happening here. But whereas week 2 S4 has already has an over plan of 50. Now you're not doing any adjustments, so this becomes the 50 plus 0. So again S4 is saying 50 and overtime is minus 50. This is coming as 0, and 168 is still there. So this might confuse you that like why we'll have S4 and then why we're doing an adjustment. So this is just to show you that what happens if you introduce a fourth key figure into this entire scheme of things. Okay, Deepak.
yes, Venkat.
So I'm creating another key figure now, saying jet and job overtime required adjusted. Just some adjustments. Adjusted overtime. Capacity planner. So that is his key figure. He'll do some adjustments. Let's just say so stored. Sorry, all editable. Saving it. So now we have overtime, and then also we have an overtime adjusted. So now where is our freeze, capacity freeze? So we already have 3 key figures here. Now I'm bringing a 4th key figure. Now let's see how the system will go for a toss here. So if the available is greater than threshold, cool, do this calculation. Overtime required plus overtime adjusted, ZM job, overtime. Okay, so if it is greater than, this has to happen. What is that? That is overtime plus overtime adjusted plus final available capacity. And if it is not greater than threshold, this is it. So now I'm doing a validation. Oh, it is still taking. Okay, I think the I'm wrong. Maybe it takes 4 key figures. It will not take more than 4, I think. So what I'm trying to say here is that, let's not complicate this. So I'll jump into the helper key
Yeah,
figure
yeah, no
definition.
problem.
Yeah, the helper key figure definition is that it's kind of an auxiliary key figure in APO. So the helper key figure is used to break up your entire calculation, break it into chunks, and then write a helper key figure for one chunk, so that you can reuse that helper key figure again and again, so that your this thing becomes uh, like easier. So let's say now I'm going to break this entire calculation, then I'll create a helper key figure now. So I'm sorry, I couldn't think of a better example, so that we can actually see like where exactly this fits in. I mean, if we have a complex calculation, then yes, we definitely have to use a helper key figure. So if this is, so let me take this chunk, and then I'll create a helper key figure for it, and I'll write this calculation in the helper key figure. Okay, so you'll go here, I'll pick up, I'm going to another tab so that I can copy and paste the formula from here to here. So now how to create a helper key figure? So it's simple. You click on the star here, new key figure, but here the second radio button is helper key figure. Okay, so usually we follow naming convention starting with the prefix as H. So now I'm going to start with H. That means H means helper key figure. So Z M job what is it, calculated overtime, give a planning level, obviously at what level this it has to do a calculation. So now this is not like a typical key figure. Like, see, you will see it. So the moment I click on OK, so you will not see all these other options that you see here. You see,
Okay.
there's no, the entire thing is gone. Why? Single reason: helper key figures are meant only for the backend calculation purposes. End user will never ever see an helper key figure. So if end user will not see it, if it is not visible in anywhere, then what's the point of giving a business description and giving an aggregation mode, giving a planning notes, etc., etc. So, and it always be a calculated. So that's why we use the helper key figure, right? Like, for example, if you take the complex mathematical calculations, so what do? So we say, let's say x, and then we declare something called x, and then we use x, and we say x is equal to a plus b by 2, and then we'll start using the variable called x in our calculations, right? So till we get the desired result that we want. Just like that here, we'll use a helper key figure, and then we just write it here. So the calculation is, I'm copy all this. So overtime required adjusted, overtime final available. Click on OK. So this would come in handy if you are writing multiple key figures and this chunk, this A plus B plus C, these three key figure summation, if that is getting repeated across, so you can just use this helper key figure instead of writing this big calculation and making it look very complex and stuff. Now I'll come here, I'll do a refresh. Yeah. So you need to do a refresh so that the browser in here you open, it will be refreshed so that it can read the key figures that are coming from the backend. The backend, that means we just created this HZM. See this? So we just created in this in a different tab. I refreshed it, then it comes in here. So now I go to my capacity freeze, edit. So instead of using this big chunk, I'll just use my helper key figure. This is HZM job. See, now it is looking cleaner. If final available is greater than minimum capacity threshold, do this helper key figure, otherwise just do this. So if I go to the graph view, okay, this is looking so crazy. So on top we have the capacity freeze at request level, and then there is a weak resource location level, and then there is this minimum capacity required. It's in yellow color, that means it's a stored value. So we have the final available here. So the final available, we are comparing it with the minimum capacity required. If it is greater than, I'll use this helper key figure. How this helper key figure is happening? Helper again is coming up with summing up this overtime required adjusted, and then overtime required. How the final available is coming in, it is coming in based on the consumed capacity, and again consumed capacity is coming from job start period and then the job duration. So yeah, I mean a pretty kind of a, not say complex, but yeah, a simple calculation only, but it is just looking using multiple key figures. So there's a better way
But
to
this
look at it.
looks very like distracted. Like, however, we are
Mhm.
using very few key figures, but still the graphical looks very complex and confusing.
Exactly. So that's why there is another key figure, other application called key figure calculations here. This dedicated app, go here. So here you'll look a better visualization. So let's go to pick up the planning, this thing called capacity freeze. This is the one. Go. So now it will give. This is kind of a decent one. So it is starting from job duration. How many hours it requires. Based on that, we'll come up with this consumed capacity. There is also a calculation written here. Now this is at a weak resource location M job. Now that is aggregating to weak resource location. Now you have now this becomes into the final available. Final available is nothing but available capacity minus consumed capacity. Now that is getting into this this thing. Now again it is becoming capacity freeze. Hey, 1 second, Deepak.
Yeah, Venkat. Mhm.
So yeah, so this is kind of a better view, right? I mean, and a few things to understand here. That is the green ones. Green ones means stored. So you see, there's a stored icon here. The calculation icon here. See the calculator. That means It's a calculated one. And you can also see
Okay.
the planning level. Hello.
Yeah, yeah, yeah.
Yeah. So yes, green means stored, and there's also a stored icon here. This is a database icon. The calculator icon means it's a calculation. Then you can also see the planning levels at the rate. This thing, some are getting aggregated and viewing. So there is expand and collapse also. So you can use that. You click on plus, then it gives you more details. So how is that? So yeah, so you click on this job consumed capacity. So this job consumed capacity, there is a, it shows the calculation. This is from a week resource location M job. This is aggregating and it is giving you week resource location. You can go to the planning levels. It is written at week resource location. If you go to further down, you have let's say this calculation. This will make more sense. So it is saying that job consumed capacity at resource location M job. So it is saying this job start is 1, then take the job duration. If the job start is not 1, just take 0. That means you're consuming 0, right? I mean, you remember those earlier calculation that we wrote here. So here, so we're saying job start is 1. That means this chemical cleaning is happening. If it is 1, it has to take 68. And where is this 68 coming in? This is a master data element. That means the capacity that it consumes. And you're saying job start as 1 here, week 1. So for oiling maintenance job, 50 comes in here. So that is exactly is being getting displayed here. Okay, this is much better, this calculation. So yeah, we're done with the helper key figure. Now write an alert key figure. Okay, before that, just read the theory of the helper key figure. This is a key. They're not visible to the end user. So it is saying 3 inputs, but thing I have to see. So we gave 4 inputs, right? But still it took.
Right.
So it is saying you cannot use the same key figure twice in one calculation. Maybe this is a previous version, I think, but now I use the same calculation. Job final has been used here again. Job final has been used here. Maybe I need to update the slide deck with the most recent content. Yes, so there does not have any key figure properties, like it is not cannot be stored, it cannot be editable, there will not be any aggregation, there will not be any disaggregation, because they're just used only in the calculation. For ease of identification, helper key figures are usually prefixed H. Okay, now let's get into the alert key figure. Uh, what is the logic for alert key figure? A simple logic that if my final available capacity is greater than my threshold, I want to have an alert. So new key figure only. So for alert key figures, we follow a naming convention called ALRT. And here we say that, or what would be the name for it? Alert. Just say M job. Just giving it maintenance. It's fine. So now I give a name. This is alert over maintenance activity. I'd give this name. So now it always has to be a calculated one. You cannot say it's a stored one. So because alert will occur based on a calculation logic, right? So here in our example, the logic is that if the final is greater than the threshold, so that is a calculation. So it cannot be a stored. And clicking on plus here, writing a calculation. If my M job final available is greater than ZM job, what is that? Minimum. If it is greater than this, yes, an alert, otherwise no alert. So alert key figure can hold only two values, 1, 0. 1 means alert on, 0 means alert off. Okay, so clicking on validate, we'll see in detail. We'll talk about it when the activation happens. So I saved the alert key figure. We're done with two. One is we used when a helper key figure comes in handy, and then we have seen alert key figure. Now let me configure a snapshot also, right? We remember you remember you take we talk like we'll take snapshots for like on the final plan. So to create a snapshot, we have to do it through the snapshot operator. So in this page, there is this start here under overview. Under the overview, click on manage planning operators. So this is where you, sorry, manage snapshot configuration. So this is where you configure your snapshots. Click on this. And as usual, pick up your planning area. So this is test conf 2. So now I'm creating a snapshot operator for the key figure called as, where is it, freeze? Yeah, for the capacity freeze. So now I'll create new. I'll say that snap capacity freeze. Snapshot type is original. The input key figure, what key figure you want to take snapshot on? So go and pick up the ZM job. Where is the capacity flow? So this is a key figure that you want to take snapshots of, right? That's why this becomes the input for this operator. That input has been selected, and then now you need to give a suffix. So like, you can take multiple snapshots. For example, so let's say you want to take a snapshot on every month, and let's say that you now we are in June 2019. So let's say we are doing for 8 months entire planning. There is this capacity freeze. So this happens after after exhausting entire capacity planning. So this is a final plan that we thought. This is a final plan that we got in the June month. Okay, so now I'll take snapshot. So that would be snapshot 1. July is done. June is done. Now, sorry. Now we move to July. So again, July, when we do the planning, let's say values got changed. So this is 150, and then this become 155, this become 150, this become 150, and this all become 150, 150. Now I'll take a snapshot too. Then this July month also passed. Then we are in August month. Again, this capacity plan got changed. It could be like for any other reason, like this thing is changing. So now again, I'll take another snapshot. So now with this, for September month, I can see how the plan is varying. So in the June month, you said that you're going to have a capacity of 145, and again in the second snapshot it changed to 150. Now it is changed to 200. So this is keep on changing. So why there is a variance and etc. And then we also know that what is actually planned in the month of June. So you're getting right.
Okay, so this is basically we are just capturing the what we say the snapshot for that particular month, like what was that time and what is currently at this time. Right?
That's it exactly.
Hmm.
And believe me, this requirement comes in like very frequently in IBP. Like we'll
Yeah.
be creating lots of snapshots, because once the entire planning activity is done, because see, these are all calculated key figures. So whatever that we have seen, this capacity freeze, it is having this calculation, and you change the numbers and the calculation changes. So yesterday you guys had a plan, a meeting, and then you came up with the final capacity freeze, and today someone changed something and it is disturbing your entire plan. But you want to take a backup of that plan, store it in a different place. So like take a snapshot of it, so that you can compare that, etc. Right? So that's why you need snapshots, and you can take multiple snapshots. So the right way to interpret is like, let's say you take snapshot on every month if the entire capacity planning is happening every month. Or obviously you can also schedule this job that you run everything, and then you take a snapshot at the end of the day. It just takes a snapshot and keeps it in the snapshot key figures. Okay, so I'm giving a suffix called mth, that means it's month. So you can see that this is how the key figures would look. So from is 0, that means from current week, till next 52, that is next 52 weeks, that is next 1 year. So maximum number of stored snapshots I will take 6, or like in our example 8. You can take only 9. Okay, so so now what system does, the system saves 8 different so you can also see the read the greatest number of time elapses photos you can take of a key figure. The most recent snapshot is 1, the next most recent is 2, and so on to the oldest snapshot. When you take a new snapshot, the snapshots are renumbered so that the new snapshot is 1, the most recent is 2, etc. The oldest snapshot is deleted to make room for the new snapshot. You can store up to 9 snapshots. We'll see that. I think this might confuse you, but anyway, 8 snapshots will be taken. That means 8 different key figures, right? So here in this Excel, we want to see all the snapshots that you took, and you want to see it all in different key figures. So that's why if you say that you want to take 8 snapshots under this operator called snapshot freeze, then 8 different key figures will be made, and they'll have a unique name with the m job capacity freeze, mth, that means month 1, 2, 3 till 8. Okay, clicking on save. This got saved, the operator got saved in under test config 2. Now I come here, if I do a refresh, you see all this can come in. Job capacity freeze underscore mth1 underscore mth2 underscore mth3 till mth8. So if I click on mth1, let's see what it has. So it gave a name automatically, and then it's a snapshot key figure is toggled on, it's a stored, it is everything got it's all It's all grayed out because system generates it. You don't generate it. You just run the operator. The system generates this. So if you don't like the name, give a different name. I'll say, snap one. I'll just change only 3. Then that's it. I'm triggering the activation. Going into the application logs. I hope I made the entire config accurately. It will not fail. Oh, okay. So yes, boss. So yeah. I'm really, sorry, I forgot this. So actually, whatever is mentioned here, this is true. That means you cannot store more than 3 inputs. But you can say that, but hey, but system didn't stop me. System allowed me when I did that validate here. Like I clicked on this tick mark, right? So it validates. So it validates there, but when you trigger the activation, during the time of activation, it will fail. And it will say that the calculation is cluttered. You have to go and work on your calculation. Please break it into smaller chunks and etc. etc. Okay, so this is still valid, so you can give it a try. Configure a key figure X, and I mean some key figure, something key figure. You write it key figure X plus Y plus Z. Write that and you validate that. It will be validated. It would be saved properly. But when you activate it, during the activation time, it would throw a message saying like you cannot use X, Y, Z, and some other key figure, all four in one single key figure calculation. Okay. As this will take some time, let's go into some theory and let's read about alert key
So,
figure.
so it giving an error during activation.
Yes, it will fail.
There's
The
no point.
activation job fails.
Yeah.
Sorry.
If the activation job fails, meaning our whole the calculation will fail, right? We don't see the result.
Exactly, yes. So it would still be in inactive status. So now this is an inactive status. This is an active status because this was activated some time back. This is inactive.
Mhm.
Then planner can say like this is inactive. Then you cannot see this. So you have to come and fix that calculation, break down that, and create helper key figures. Then give an activation run. Maybe at the time it gets completed successfully. Okay, so some theory on alert key figure, straightforward, whatever we discussed till now. So it says that key figure that monitor and manage the execution of business plans based on user defined criteria. Alert key figures are always calculated. Yes, they cannot be stored or edited. Yes, they can have values of 0 or 1. Alerts typically check conditions on other key figures, such as target revenue versus consensus revenue is greater than 10%, etc. Next are snapshots. To check how key figure values have evolved over time, you can capture and compare multiple historical snapshots over of a key figure. The key figure values captured by a snapshot are stored in a snapshot key figure. They are displayed in your planning view in Excel along with your other key figures. Yes, the snapshot key figures are displayed. This thing. A snapshot captures key figure values at a particular point in time. That is when you run the snapshot operator. You can keep up to 9 snapshots depending on your configuration.
Venkat,
So now you may.
the question. So
Mhm.
for the key figure, right?
Yes.
Let's say the key figure. How I can understand how the transformation is happening. Like now here we are configuring, right? So we know like this is a calculated key figure, stored key figure. But if I want to, there is a key figure or the value, and wanted to check the how that is coming. Like maybe it's an interface or whatever. So what is the way to understand the key figure details?
Mm. So you mean to say if like if key figure Z is A plus B plus C. So you want to know how the key figure Z has been made, how the values are coming in.
Yeah.
So if it is 10, if it is 20, this is 30. This is the calculation that you wrote. So if you want to know why Z is 60, then you obviously have to go and see the calculation logic, how it has been configured. The key figure configuration screen shows that it is a summation of A, B, C. Then in your planning view, bring the key figures A, B, C and verify the values 10, 20, 30, and you will see the Z as 60. That is one. The second thing is if the interface is bringing in, there is no way from here that we'll know that interface is bringing these values. For example, this thing, standard available capacity. So if this is coming from interface, there is no button here which says that this is coming from interface. So the planner should be well aware of the key figures, that what is being interfaced, what is a calculated one, what is the manual entry one, what is the output of some operators, like output of snapshot operator or output of copy operator, etc., etc. So that's why yesterday we're talking that we have to build up some kind of a tracker, a key figure configuration tracker, where we list every single key figure, and we also say what is the source. So with that, the planner will get educated on the key figures, and then if it is based on a key figure calculation, if it is based on ABC, he can open ABC and see the values by himself, and he'll understand that okay, the Z is showing 60, that means calculation is working fine. So in case of other interfaces, then if the interface is coming from S4, he has to go to S4 and verify whether the originally in the source, if the value is 60 or not, something. So that is the only way.
It's challenging then.
Mm. No, it's not at all a challenging. I mean, uh, maybe initially it takes some time, but eventually the planners will be this thing. I think the same is the case with APO also, right? I mean, in any other, even in BPC also, we have the key figure concept and there is a calculation concept there. So the planner, I mean, once he understands the entire the planning process and what all data points are involved in this process, then yeah, it may take some time for him to go and verify why is this, why is like that. But there are other things like forecasting thing. So that is yes, I would say that would definitely confuse, because if you say that the forecasting has to happen on linear regression and then you say you maintain some alpha and beta and gamma, if your sales history is 100 or something like that, and it will give you a forecast. So now if you ask like why the forecast is this, why the forecast is coming as 150, no answer. So we cannot answer that because the statistical algorithm gave the output as 150, and that's it. We have to live with that. Um, outputs from the optimizer run or a heuristic run or something, or inventory optimization also. Even those could be almost we can explain that, like why this operator is giving these kind of values, uh, but not in also in complete, because they are it's an algorithm. There's some logic goes behind, and we don't know in complete detail like how that algorithm has been configured. I'm sure that it's thousands of lines has been coded behind it. But simple operators like copy operator, like the snapshot operator, we know, like when we run a snapshot, we know that it has to take a snap of the values that are present in that key figure. So that could be explained. Think we are about to get done. Activation successful. So how much time it took? We started at 8:32. It's done at 8 for 10 minutes. Okay, big deal. So now I am logging back into the test conf2. Yesterday we saved a template for maintenance planning, I think. Yeah, this is what we configured. So let's go to the final plan. Okay, so let me bring up the key figures that we configured. First I'll bring up the threshold one, minimum capacity. Yes, this is the one. So now alerts. There is a last pan here, time selections, planning level selections, key figure selections, layout, filter, alert. Let me so I'm giving some minimum 120. I'm just maintaining 120 across. What? This is only readable for past periods. What the hell? How did we configure it? So readable in the I don't know why I selected readable in the past. Oh no. Okay, let me give it a try. Let me go back and see if we can. Going few weeks back. Hmm. Yeah, so now they are saving. I don't know why I give editable as past. So getting right, so it is taking only for the past values because I configured that the key figure is editable only in the past. So now let me
So now, if we edit that key figure, then will not change the.
yeah, it will not. So see, 24th is a current week. I gave 120 here and I save it. You have 0 valid changes. Final plan template. The following key figures are only editable for past time periods. That is minimum capacity required. One changed cell. So because I configured this, where is that minimum capacity required? This is editable in the past. That's why it is doing it like this. So let me just let's see if other key figures I made them as a fully editable or not. Because if other key figures, if I okay, great, great, they are editable in the past also. I think I made them as all editable. Otherwise, like what I have to do is I have to go and change this and reactivate. It will take some more time. Now let's continue with the planning in the past buckets. So going here, so now see, I think I don't know I've explained this to you or not. So this first sheet is a maintenance plan. This, the planning level is at resource, location, maintenance, job. The second sheet is a final plan. Here the planning level is resource and location. It has a different key figures selected. There are 4 key figures selected here, and here in the maintenance plan there are 3 key figures are selected, different key figures, and then the time horizon is different for maintenance plan. The time horizon is different for final plan. So now you can copy the settings from sheet to sheet. How to do that? There is a button here. You click on this. So it gives you copies. What settings you want to copy? You want to copy the time horizon that you have selected, or is it a planning level, or is it the key figures, is it the planning nodes, or is it the conversions or filters? Conversions is that unit or measure conversion. So I want to copy the time settings. Time settings from final plan to maintenance plan. So now you see the final plan has a historical time period selected, but whereas for the maintenance plan, it is from the current period, 24 the week of 2019 to 2020th week. So 98 weeks have been selected. Now if I copy it here, so now you see this maintenance plan is also getting the previous these things. So that way, you can effectively, play with your sheet. So now I gone back and thankfully, even these are editable. So now I'm maintaining it randomly. So I'm just flagging them on. So that means the maintenance activity has to happen. I'm saving them. They got saved. Great. Now if I come to final plan, I will see some consumed capacities. Okay. Shickety bricket. Yeah, it will not show consumed capacities. Why? Because the duration for the maintenance activity, it doesn't have the historical periods. So let me open that. Remember this job duration, a master data element, which we configured attribute as a key figure. So now I think these are not editable. Yeah, these are not editable. The attribute as key figure, the job duration is not editable. Okay, Fine. So let's do one thing. Just for our this purposes, I'll say this is 100. I'm making the standard available as 100. Just for our, uh, you know, just to see the alerts. I'm changing the standard available capacity itself. Now final available capacity has got changed. Now I go to edit. You following with me, Deepak? Hello.
Yeah.
Yeah. Okay. Highly surprising. Why the alert is so usually the alert should be coming in here. So the alert that we have created. Where is my alert? ALRTM job maintenance. This is final available is greater than the capacity minimum required. Yeah, this is all fine. Okay, anyway, let's not stop. No, it's already time is. See, there is another alert key figure. It's called alert for recommended safety stock. The definition is that if the recommended safety stock is 0, then I want to have an alert. Otherwise, it is there is no alert. So now just to show you that. First I'll show you how the alert key figure works, and later on I'll see why this thing is not working. Great. So see, in the edit view, as I said in the last tab in the alerts, so if you click on add alert, then system would show you all the alerts that are already there configured. So the alert name is alert for recommended safety stock. So then the second column is you want to highlight which key figure. So I want to highlight the recommended safety stock. So you can give the color that you want. So you can say that I want to color code with like this. Okay, and then the scenario is baseline version is the base version. So we'll see there. So this is how you can configure how you want to look at the alert. So now the color got changed to the pink. You see, you're getting right.
Yeah, sir.
Yeah. So this is how you write your calculation, and then let's say if you have huge data set, then it becomes simplified. So this comes in green. I go to let me maintain the data from the backend, weak resource location, edit mode. So once you configure that key figure, so it would be available for all the planners. So let's say the entire team can have. Okay. Bloody hell. So we got some safety stocks which were recommended for these locations 1002 for the product called SFG, semi-finished good Y, semi-finished good Z, etc., etc. So, but somehow the safety stocks were zeros for some, products in a location. So now with the alert key figure, where all the alerts are coming in, 0 and 0, 0. So you can change the color that you want to see. So what's up with the alert key figure then? So alert key figure is a calculated, but it stays in the backend. It will not be. I mean, it can be displayed in on the planning view, but usually it will not make sense to see it. So now I can bring up that key figure also. Is it alert recommended safety stocks? So now it either have 1 or a 0. So 1 means alert is active. So in this time bucket, it is 1. So that's why system has made it to 0. I mean, system has color coded that recommended safety stock. So you understood, you understood, right, Deepak?
Yeah, yes.
Yeah. So, but I don't know why this is not working in the configuration that I did. But anyway, I'll get into that. So that's one, and let's see the snapshots now. Let me go to the current bucket, because we said snapshots has to be taken from the current period. Standard available. What is that? Overtime required. Capacity freeze. One second. Let me log into our planning area, test config, where we have configured the snapshot operator and stuff. Seems this view got corrupted. Let me close this and reopen the template once again. I'm editing the view. I'm opening from the current bucket 24 till the future. That's fine. Location resource is fine. So I have the standard available, final available. There is this overtime required, and then I do all. And finally, I come up with the capacity freeze, and then I also include the snapshots. It is saying there are no filter. That's fine. Okay, so this is my standard, this is my final, and I'll say that I'll do a overtime of let's say 50. Let's deal it for only this combination, plant 101, manual assembler. You also need the minimum. So there is no minimum capacity because it is only editable in the past. So let's see. Let's do one thing. Hey, you know, Deepak, let me edit that key figure. I'll save it. So tomorrow we'll see the that snapshot and everything tomorrow. Okay, because the activation is taking some time. Okay, so let's just quick recap on what we have seen today. So first we have three key figures we have seen. So first is a helper key figure. So helper key figure, not like a typical key figure. We won't get the typical key figure properties. It will not be stored, it will not be edited, it will not have any aggregation, etc. It's just an auxiliary key figure, a temporary, intermediate, technical, backend related calculation key figure. We can write that and we can reuse the helper key figure across. We have seen the alert key figure where it should have a calculation and it should have either a 1 or a 0. 1 means alert is on, 0 means alert is off. So you have to take that alert and map it in the Excel planning view. In the last pan, there is this alert pan. So you have to go there and pick up the alert that you have already configured, and you specify what key figure you want to highlight and the type of formatting that you want to give, whether it's a bold or what color it has to have, and then okay, and then you can see that a particular cell where the alert is on, you can see that getting highlighted. Third, we have seen a snapshot, uh, uh, I'll say operators. First, you create an operator and you say that you want to take a snapshot on what key figure and how many snapshots you want to take. And then you can go and change the name of it and then, save it. And then we'll see how we run the snapshot operator, how the results will come in tomorrow. Okay. Okay, Deepak. Thanks
Yep.
then. We'll catch up tomorrow. Yeah.
Yeah.
Bye.
Have a good day.
Thanks. Bye.